Welcome to Math with Mrs. Bibb. Today we will be simplifying radicals and working on operations with complex numbers. We're going to simplify, and I'm going to rewrite those little facts again. You don't have to rewrite them, but I just want to. So if I see I squared, I'm going to replace that with -1. And if I see the square root of -1, I will replace that with I, not vice versa. Just if I see I squared, then put -1. If I see the square root of -1, then put I. Okay. Number 1, simplify. I'm going to add like terms. That's basically what this says. Add like terms. 5 is like terms with 7. So 5 plus 7 is 12. Positive 1i is like terms with -8i. Positive 1i plus -8i is -7i. I do not see an I squared. I do not see a square root of -1. So my answer to that problem is 12 minus 7i. Number 2, it tells me to subtract like terms. I would encourage you to distribute a -1 to both of these. I'll go ahead and distribute a +1 to these, just so I can get rid of those parentheses. So if I distribute +1, then this is 12 plus 2i. If I distribute -1, this is -7 plus 4i. Then I'm going to combine like terms. Now let me talk just for a second why I did not do that here. We're just adding here. But this subtraction sign makes some complications, especially with this second term. So I would encourage you to distribute a -1, but if you're good at subtracting both of these, you do not have to do this here. But I encourage you that if you need to do this, please do. I usually will, just because it helps students that struggle with the subtracting a negative. It helps them see, why the answer is what it is. Okay, so my like terms, 12 and 7 minus 7 give me 5. And positive 2i plus 4i gives me plus 6i. So my answer is 5 plus 6i. I do not see an I squared. I do not see a square root of -1. Now the next problem, on purpose, I did not put a complex number here. I put just a regular 2 binomials being multiplied. 2 binomials being multiplied. This was addition, this was subtraction, this is multiplication. So when we multiply, remember, we're going to distribute. We're going to take the first term, x, and distribute it to the second binomial. And then we're going to take the second term, -4, and distribute it to that second binomial. And then I am going to distribute. So 3x squared plus 2x minus 12x minus 8. And then combine like terms. 3x squared minus 10x minus 8. That's my answer to number 3. And again, I don't have I squared or square root of -1 because there's not a complex number there. But if you look at question 4, I have 5 minus 2i. There's that complex number, imaginary unit I. 6 plus 3i. I use the same process. I am multiplying. I'm not adding or subtracting the way I was here. I am multiplying. So I'm going to use that same process that you did with binomials in Algebra 1, and I'm going to multiply 5 times the first term of the first binomial times the second binomial, 6 plus 3i. And I'm going to multiply -2i times 6 plus 3. I'm really missing my Apple Pencil. can't tell that's a 3. Okay, that's a little better. Now I'm going to distribute. 5 times 6 is 30. 5 times 3i is 15i. Negative 2i times 6 is negative 12i. Negative 2i times positive 3i is negative 6i squared. I'm going to combine like terms. 30 plus 15i minus 12i is positive 3i. And I see an I squared, so I'm going to replace that I squared with negative 1. So I have 30 plus 3i minus 6 times negative 1. I'm going to go ahead and do that multiplication. 30 plus 3i plus 6. And now I have like terms. 30 plus 6 is 36 plus 3i. That's my final answer. So the answer to the product of two binomials is going to be, for the most part, a binomial. There are exceptions to rules, though, so there may be an exception to that rule as well. Stay tuned. If you look at number 5, I do have a product here. I'm going to multiply. I do not have complex numbers, though, so I'm going to multiply this binomial times this binomial using the same procedures I did for number 3 and number 4. I am going to multiply 2x, the first term of the first binomial, times the second binomial. Then I'm going to multiply positive 7 times 2x minus 7. I'm going to distribute 4x squared. 2x times 2x is 4x squared. 2x times negative 7 is negative 14x. Positive 7 times 2x is positive 14x. And 7 times negative 7 is negative 49. Now I'm going to combine like terms. Negative 14x plus 14x, that's 0. So I would get 4x squared minus 49. That's my answer to number 5. And notice again, there were not complex numbers. Now I'm going to multiply 3 plus 4i times 3 minus 4i. I'm going to use that same process because it's binomials. So I'm going to multiply 3 times 3 minus 4i. And I'm going to multiply positive 4i times 3 minus 4i. I'm going to distribute. 3 times 3 is 9. 3 times negative 4i is negative 12i. 4i times 3 is positive 12i. 4i times negative 4i is negative 16i squared. I'm going to combine like terms. Negative 12i plus 12i is 0. So 9 minus 16, there's I squared, so I have to replace it with negative 1. I have 9 minus 16 times negative 1, so I'm going to multiply. Negative 16 times negative 1 is positive 16, so I get the real number, whole number, 25. Okay. The next thing that we're going to talk about. You can't see those little fraction bars for the notebook lines. We're going to talk about complex conjugates. Two complex conjugates that are multiplied, or the product of them, is always a real number, which you can see that from that last example. So the conjugate changed the addition sign to subtraction and vice versa. Let me talk about a couple of examples. So if you have 5 minus 2i, the conjugate of 5 minus 2i is 5 plus 2i. You are simply changing the sign here. So the conjugate of 5 minus 2i is 5 plus 2i. I'm going to draw an arrow and write that. The conjugate of negative 3 plus 8i. Again, you are only changing this sign. So the conjugate of negative 3 plus 8i is negative 3 minus 8i. Okay. Oops, I did not write that. Hold on. Negative 3 minus 8i. Okay, rationalizing the denominator, just like a fraction, is not simplified with a radical in the denominator. It is also not simplified with a complex number in the denominator. You multiply by the conjugate to simplify. So I'm going to multiply by the conjugate of 4i, which in this instance, it's just like, let me show you, and then I'll erase it. You don't have to write this down. If we were going to simplify this, we would multiply by the square root of 2. That's just how you rationalize the denominator. When you have a radical, just multiply by the radical that's there, as long as it is simplified. Now, if you had this, then you would multiply by the conjugate, 1 minus the square root of 2, to simplify. So this is the same thing when I'm looking at complex numbers. I do not want I in the denominator. And really, you can just multiply by I. That will get rid of the I from the denominator if you just multiply the numerator and the denominator by I. So this is what my problem looks like. 6 minus 5i times I over 4i squared. I'm going to distribute that I in the numerator. So I would have 6i minus 5i squared over 4i squared. Now I see I squared, so I'm going to replace those with negative 1. So 5 times negative 1 over 4 times negative 1. And so I'm going to have, and I'm going to put this in the correct form. My number that does not have an I would go first, so positive 5 plus 6i divided by negative 4. Now, you will probably not see this answer this way. It would probably be written like this, negative 5 minus 6i over positive 4. I will accept either of those. So if you stop here, I totally understand. You can stop there. But more than likely, it would be this. Just be able to recognize how they would go from here to here. They just don't normally put a negative in the denominator. So that negative would go to the numerator. Those are equivalent. Just keep that in mind. Okay, number 8. Number 8, I'm going to multiply by I again. And that problem looks like this. 8 minus 3i times I over I times I. And I make those i's that way just so that, I don't know, to me it looks like a complex number and not just the letter I. Okay, I'm going to distribute 8i minus 3i squared over I squared. So 8i minus 3 times negative 1 divided by negative 1. I will have, I'm going to go ahead and simplify that. I would have positive 3 plus 8i over negative 1, and in this case you have to simplify that to negative 3 minus 8i. It would not be proper to leave that negative 1 in the denominator. Okay, on to question 9. I'm going to multiply by the conjugate, so I'm going to multiply by 4 minus 2i. Okay, that's going to look like this. 9 times 4 minus 2i divided by 4 plus 2i times 4 minus 2i. Going to distribute 36 minus 18i divided by, and I'm going to do the same process I did on the last problems. I'm going to multiply 4 times that second binomial, 4 minus 2i, and then I'm going to multiply positive 2i times that second binomial, 4 minus 2i. Let me highlight to show what I'm talking about there. So I'm going to multiply 4 times 4 minus 2i. That's this and this. And then I'm going to multiply that looks very similar. Hold on, I'll use yellow. Positive 2i times 4 minus 2i. Positive 2i times 4 minus 2i. Now I'm going to distribute. I don't have anything to simplify in the numerator. I'm going to distribute in the denominator. And I get 16 minus 8i, it's a subtraction sign, plus 8i minus 4i squared. And then I'm going to simplify in the denominator. 36 minus 18i divided by, these two combine and cancel out, divided by 16 minus 4 times negative 1. And then I'd have 36 minus 18i over 16 plus 4. So that would be 36 minus 18i divided by 20. Now, this is not finished because it's not reduced. This fraction, this term, and this term all have a common denominator, all have a common factor. So I'm going to simplify all those by dividing them by 2. So that would be 18 minus 9i divided by 10. That's the answer there. And I don't have enough space to do 10, 11, and 12, so I'm going to stop my video just for a minute and duplicate that slide so that I can finish 10, 11, and 12. Now I will distribute after I change that to a pen. 6 times 6 minus I squared root of 7 minus I squared root of 7 times 6 minus I squared root of 7. And in the denominator, I would have 6. Oh, I see a mistake. There's a 7 here. I'm sure some of you already saw that, and I didn't see it till just now, and that's okay. So 6 times 6 minus I times the square root of 7 plus I times the square root of 7 times 6 minus I times the square root of 7. Okay, now I'm going to actually do the distribution. 6 times 6 is 36 minus 6I squared root of 7. 6 times negative I squared root of 7 is negative 6I squared root of 7. Negative I squared root of 7 times 6 is negative 6I squared root of 7. Negative I squared root of 7 times negative I squared root of 7 is positive I squared times 7. Square root of 7 times the square root of 7 is 7. And then in the denominator, 36 minus 6I squared root of 7 plus 6I squared root of 7. Positive times a negative is a negative I squared times 7. Okay, now let's simplify the numerator. I want to point out really quickly, negative 6I squared root of 7 and negative 6I squared root of 7 will not cancel out the way negative 6I squared root of 7 and positive 6I squared root of 7 will cancel out. So in my numerator, those are like terms. The green ones are like terms. I'm going to bring that 36 down. Negative 6I squared root of 7, negative 6I squared root of 7 is negative 12I squared root of 7. I want to show you this I squared root of 7 is like a variable. It's going to stay the same. You have negative 6 of these and negative 6 more of these, so you have negative 12 of these. So don't let that messiness confuse you. It's just like a variable. I squared root of 7, I squared root of 7. You just, when you're adding and subtracting, those are like terms because those are the same. So you just combine them. And then when I do this here, I'm just going to write this as negative 7 because I squared is negative 1. So don't forget, this is negative 1, this is negative 1. So that's going to be negative 7. In my denominator, I'm going to have 36 and then minus negative 7. So that would be plus 7. And my final answer here is going to be 36 minus 7, I believe is 29, minus 12I squared root of 7 over, I have no idea if I'm going to be able to squeeze this in there, 36 plus 7 is 43. I think that looks correct. So my final answer, since 29, 12, and 43 do not have a common factor, is 29 minus 12I squared root of 7 over 43. Let's save number 12, since we've done enough. Let's save number 12 to do together in class. So someone remind me. We'll do number 12 before we do the assignment. So we'll do that one together in class. And I want to go back to one of the slides before, so here it is. I want to just talk quickly about what all those letters stand for in the blue and just in the blue. So this Q stands for rational numbers. So if you see the letter Q, that means the set of rational numbers. The I stands for the set of irrational numbers. Irrational. And then, so real numbers are broken down into rational and irrational numbers. The set of irrational numbers, that's it. We're talking about the square root of 2, the square root of 5, the square root of 7. So any radical that would produce a decimal when you would take the square root of it. Pi is also an irrational number. The definition of irrational numbers is this set of numbers in which a non-repeating, non-terminating decimal is found. So if you took the square root of 7, square root of 5, square root of 2, then those decimals do not terminate and they do not repeat. And pi is the same thing. Pi does not terminate, it does not repeat. So irrational numbers, that's what those are. Now rational numbers include integers. So that's positive numbers and negative numbers, and that does not look like an E. Integers. So negatives, 0, and positives. -3, -2, -1, 0, 1, 2, 3, so on and so forth. And then within the set of integers is the set of whole numbers. Whole numbers include 0, 0, 1, 2, 3. And then natural numbers do not include 0, 1, 2, 3, so on and so forth. That is something you should know, and I'm not sure what grade level you're taught that, but I think it's something you should know at this point. And then, look, I had rewritten this. Right there it is, pure imaginary numbers, A equals 0. But anyway, imaginary numbers contain that I part. Okay, that's it. Hope you have a wonderful day. Sorry these are so long.